You guys want to grab your note packets and turn to where we are with the area principle?
Ah, where's the thing?
I'm going to do something real quick. And I'm going to do this, all on video because I don't feel like turning it off and back on. Because that's a lot of work. Right? And really, the point of recording the lectures is so it's like you're here, right? You feel it. That seems to be a pretty common case. Does my toolbar come back up? Yeah, there's my toolbar. Good. All right. So, when to use a bar chart versus a pie chart, we kind of talked about that with the homework, but in general, pie charts are best when used with recognizable fractions. If they have a lot of categories, they're difficult to read, so pie charts usually aren't great. If we have multiple categories with very similar counts, pie charts usually aren't good. Bar charts are usually better. Again, all of these things are just about trying to make it readable for people who are having to read your graph. Okay. What I kind of see it as is if you're using the chart incorrectly, it means one of two things, right? If you're doing it incorrectly, it means either you are ignorant of good chart practices, right, making things readable, or you are trying to deliberately deceive people. And if you're a journalistic agency and either of those two things falls under what we're talking about, then you've got some problems as a journalistic agency, right? If you're a news agency that can't make a readable chart because you don't know how to make a readable chart, then that's bad for you as a news agency, and I shouldn't trust you. And if you're doing it to try to deliberately deceive me, then again, I shouldn't trust you as a news agency because you're deliberately trying. So, for me, when I see bad charts and that on the news or in the newspaper, it always raises a red flag as to how much should I trust this particular author or news agency. Okay. The other one that comes up real big is what's called the area principle. And the area principle basically just says that areas in a display need to be proportional to their counts, right? We as humans tend to be more impressed with area than length. When we see something as bigger in a proportional way, right, two-dimensional, right, we think that's more impressive than simply the length. In the book, you've got this nice chart of the Titanic, but instead of using a bar to show things, they show like actual pictures of the Titanic, but they make them like proportionally larger. And so even though two of the bars are very similar, one of the ships looks significantly bigger because of the change in proportions. And you don't want to do that. You want to avoid that because it makes things look incorrect, right? You can, again, try to deceive when you're doing it. This shows up the most in 3D charts, right? When you've got charts that are in 3D, you really need to be extra careful about doing that. For me, I just say don't do 3D charts because 3D charts are going to mess things up. For example, this is a bad chart. This is our M&M data right here, right? This is the M&M data from the previous page, last year's, right? Because we didn't put this year's in. So if you notice about this, our largest percentages were green and blue, right? But when you look at that chart, what looks like the biggest percentage? Red and brown. And those were the lowest. Okay? 3D charts are bad because the perspective is all wrong, right? And this 3D, like this little chunk of the graph that we see down here, there we go. I'm trying to get my mouse show up. Ah! Stop it. Go back. that little chunk of red that we have down here makes it look a lot bigger, even though it's not, right? Same with this little bit of brown, and the angle that it's at is messing that up. Because clearly, some of our, that's not right. That's not 20%. That's not supposed to be. What happened? I don't know. I think these got switched. That's weird. Anyway, even if these were, right, they look so much bigger in comparison that it really deceives our eyes if we don't know the actual percentages. So don't be that guy, right? Don't make 3D charts because it's just gonna get messed up. And if somebody makes a 3D chart and they're using it in a news article, laugh at them and make fun of them and make them feel bad about themselves because they shouldn't be doing it. All right. And come on, 3D is stupid, right? Which is weird because that used to be in 3D, and I don't know why it was a 3D thing, and now it's gone. So anyway, that's blank intentionally. So contingency tables. This is our data here from what we did earlier. This is the political makeup of our classroom. Typically, I was going to say that we would have we typically have more moderates than this. This is the first year where I've had a class that's been so divided. It's usually where we get smaller numbers of liberals and conservatives, and then really large numbers of moderates, and it kind of fits that. But there's a lot more divisiveness in this class than I've had in previous ones. The reality is that most of America is moderate, is in that middle area, or at least very close to moderate, depending on how you define it. So anyway, that's our political makeup. This is a contingency table. In a contingency table, we have our margins, right, along the side. Those are typically telling us what the categories are. What I want to note about this is that a contingency table is two variables, right? In this case, we have political leanings, and we have gender. So that's two variables, whereas pie charts and bar charts are one variable. Right? A pie chart and a bar chart is one variable. It's measuring one thing. In this case, our contingency table measures two variables and it compares them to each other, right? We have the gender variable, which gives us males versus females. And then we have our political leaning variable, which tells us if we're liberal, moderate, or conservative. And then all of these boxes in between are, like that box is the number of male liberals. The moderate liberals male moderates and male conservatives, female liberals, female moderates. So a contingency table is measuring two variables. I didn't change it in all the other ones. Let's go back. Let's fix this. We're going to answer the question. 154530. 154530. Right. 154530.